Hello, welcome to the video. So you are here, that means you want to find the area of this green shaded region. So let us find this together. So in this question we want to find this green area, and here we have a circle, this circle, and its center is O. Now what comes in our mind is, what is this ACB? So it is also given in the question that ACB is an arc drawn from Odes edge center. So if we will take Odes edge center, then we can complete this circle. It will look something like this. Odes edge center, it looks something like it's not very perfect, but it is what the question has given. So the concept is that if there is a circle, then angle at the center is twice the angle at the circumference. If this is x, then this is 2x. So using this concept, if we have theta here, then this will be 2 theta, and we know that AB is a diameter and it is a straight line. So 2 theta is nothing but 180 degree. That means theta is 90 degree. So now we want to find this sector Odes ACB Odes. We want to find this sector. So area of sector Odes ACB Odes. This sector is given by pi r square. R is for this circle. Odes is center. So Odes and B, this is the radius. Similarly, Odes and A is also the radius, because ACB is drawn by taking Odes as center. So there is no doubt that Odes B is the radius of circle having center Odes, and Odes A is also the radius of circle having center Odes. So area of sector Odes ACBO is given by pi r square. Let's Odes B square r square into, this is a complete circle and we want just for area, just for theta, which is 90 degree. So this will be 90 divided by 360, which is 1/4 of the total area, pi r square. Now we want to find Odes B. Which is the radius. So to find Odes B, if we will see this AO Odes is a triangle. OB Odes is a triangle, and because Odes B and Odes A is the radius, that means this one is equal to this one. So this is an isosceles triangle. That means this angle will be equal to this angle. If this is 90 degree, so this has to be 45 degree. this has to be 45 degree, this has to be 45 degree. How? So we can easily calculate this 90 degree plus this angle, let's say x1, this angle x2. x1 and x2 are equal, so let's say this is x1, this is also x1. x1 plus x1 is equal to 180. So 2x1 is equal to 180 minus 90. x1 is equal to 90 minus 90 by 2. So this is 45. So x1 x2 is 45. OB and OO dash is also radius. So this OB will be equal to this OO dash because this is radius. OB is 10 and 10 meter. That means OOB is also 10 meter. That means in this triangle, this angle will be also equal to this. So we just calculate this to be 45. So if OO dash is there, this will be also 45. Similarly, this will be also 45. So what I want to say is, if we draw a line from O to O dash, it will be perpendicular, because if this O dash is somewhere here, somewhere here or here or here, anywhere else, then this angle may be 90 degree. This angle will be 90, but this will be never equal to this. This will be never, this side will be never equal to this. That means O dash is the midpoint of A O dash B. This is the only condition where this side O dash B will be equal to AO. So what I want to say is, this O dash is perpendicular to AB. This is what I want to convey. First we'll calculate this radius OB dash. First we'll calculate the radius OB dash here. This is O, this is O dash. I said this will be perpendicular. This is B. We want to calculate OB dash, this one. So by using Pythagoras theorem, O dash B equal to under root O dash square plus OB square, and these are the radius. This is the radius of original circle, this one, so they will be equal. Let's say it is given also, it is 10 meter. It is 10 meter. So this is 10 square plus 10 square equal to 200. This is equal to 2 root 10. So OB we calculated. Now we'll put OB here to calculate the area of this sector. So area of sector is paste here. So area of sector O dash ACBO is, sector is pi OB dash is 10 root 2 square into 1 by 4. So this is pi into 100 into 2 into 1 by 4. So we'll cancel 2. This will be 50 pi. So area of sector ACBO dash A is 50 pi. Now if we'll subtract this triangle, we will get our desired area ACBOA. So let's find the triangle. Let's find the triangle A O B O dash. This is perpendicular and this is radius. This is also radius and which is 10 meter. So area of triangle OBO dash is half into base. Base is this AB, which is the diameter of original circle. So this will be 2 into 10, 2 into 10, twice the radius. Radius is 10. So base will be 20 into height. Height actually we don't need it. We don't need to calculate because this is nothing but the radius. This will be 10 only. So area of triangle is 20 into half into base which was 20 into height. This height is nothing but radius of original circle which was 10. So this will be half into 20 into 10. 5 means 100. Area is 100. So now our desired area. This green area is nothing but this sector area minus this triangle. So we have all calculated. So let's put the value. Desired area is equal to area of sector minus area of triangle this triangle. So area of sector minus area of triangle. Area of sector we calculated to be 50 pi. Area of sector 50 pi. So 50 pi minus area of triangle. Area of this triangle that we calculated here, which was 100. So 50 pi minus 100. 50 will take pi is equal to 3.14. Then 5 4s are 20. 5 1 are 5. 7 5 is 15. 157 minus 100. So this will be 57 meter square. So this is the shaded region.